have already done some straightforward factoring and solving of equations. What we're doing now is we're taking it a step further. Instead of dealing with stuff in quadratic form, which is what we're accustomed to factoring, we're going to go into all the other polygons. All our different exponents are going to change up and all that, and so on. So what I want to do is just briefly remind you guys of a few things when it comes down to factoring. Not only does he like you, he's throwing your stuff. He's trying to sabotage you. Man. Right. Real quick, what's the first rule of factoring? Good. Find the GCF. That's always your first rule of factoring, ladies and gentlemen. So if I have a problem where it says 4x squared minus 24x, and I have to factor that, what's the GCF? 4x. So if I factor out a 4x, I'm left with x minus 6. Am I done?
Yeah.
No. Never.
Yes.
Oh.
Do you see an
You're right.
Do you see an equal sign?
No.
No. So am I done?
Yes.
Yes. Yes, sir.
Equals 0. Just divide it by 4.
No. If it equals 0,
So
you said each part equal to 0.
Oh, so 4x equals 0 and x minus 6.
Yep. 0, 0 would be 0 and 6. Also, when it comes into 2x squared plus 11x minus 21, that's a leading term coefficient not equal to 1, is it? Which means you have to factor by grouping. So you would multiply. Let me put this on a separate sheet here. We're going to factor it out by grouping. What's 2 times 21?
42.
All right. What times what is negative 42? You add together to get positive 11. 14 and 3, good. So I want positive 14 and a negative 3. So we write it out. 2x squared minus 3x plus 14x minus 21. Remember, what we're doing here is we're creating 4 terms. Whenever you have 4 terms, we do what's called factoring by grouping. We're going to do the GCFs of both of these. GCF of 2x squared and a 3x is x. I'm left with 2x minus 3. Over there, the GCF is 7, and I'm left with 2x minus 3. Are those two things in the parentheses the same thing?
Yep.
All right, that's a good sign. Write it down. And then what's left? And you're done. Yes, sir?
I think I remember you telling us, but I'm not sure the answer. Does it matter which way, like the plus 14x and the minus 3x, can you switch those? Does it matter?
It doesn't matter. It really doesn't matter because you're still adding them to get to 11. The only reason why I usually put the negative one first is that it's less hassle with the sign.
Right.
That's all. That's the only reason. So we remember this vaguely. So what we're doing today, though, is we're going to deal with different exponent rules. We're looking at new stuff. For example, we're looking at what's called the sum and the difference of cubes. Now, you guys have seen this. X squared minus 4, if we had to factor that. Remember, we would ask ourselves, is this a perfect square? Is this a perfect square? Is this a subtraction symbol? So what were your 2 terms then? Okay. Now, what's going to change is that we're no longer dealing with just a square. We're dealing with a cube. So we use the following pattern. X cubed, I'm going to use something real simple, plus 8. Real fast, just in case you forgot how to find cube roots. On your calculators, if you press the button that says math, I believe it's number 4, it says cube root. And then you can just see what the cube root of something is. Okay? It'll do that for you. Okay?
Press math.
Math, yeah, hit math and just, okay? So that's how you can check to see if something's a perfect cube. So Here's the pattern that it happens when you have cube roots. Is x cubed a perfect cube?
Yeah.
Is 8 a perfect cube?
Yes.
What's the cube root of 8?
2.
What's the cube root of x cubed? X. So here's the pattern. Since this is a plus sign, you always write down, the first term is going to be a plus. You always keep it whatever this is. What's the cube root of x cubed? What's the cube root of 8? 2. Now, in the parentheses, you're going to have a trinomial. You got a binomial, then you're going to multiply it into a trinomial. Since your first sign was a plus, that means the next two signs are always going to go minus plus.
So if there was a minus, it would go plus minus.
Very good. Oh no, sorry. If it's a minus, and I'll get to this in a second, I'll show you that there's it goes plus plus because all you do is this one always stays the same, this one's the opposite, and the last one is always positive. And I'll show you guys the minus one here in a second. I'll put them up next to each other. Now, in order to figure out the next three terms, all you have to do is, well, what's x squared? What's 2 squared?
4.
What's 2 times x?
2x.
And that would be your term. That's your answer. Okay? Same exact idea if I have x cubed minus 64. I believe 64 is 4. Cube root of 64 is 4. All right. What happens now, we have a binomial and a trinomial. You always keep the sign that you start with. Your next sign is always the opposite, and the last sign is always positive. So if it's a negative cube, it's always going to be minus plus plus. If it's a positive cube, it's always going to be plus minus plus. Those are what the signs always look like. Okay. Again, the cube root of x cubed, cube root of 64, x squared, 4 squared, and then what goes in the middle? 4 times x. Okay. The pattern that happens here when you're looking at sum or differences of cubes, is in as A's and B's, and leave it up. You get those are the two patterns. All right. Those are the two patterns that always work. The only trickiness that you're going to see with something like this is that not only can you have a perfect cube with x cubed minus 64, it might be written like this. 8x cubed plus 125. Oops, sorry, I screwed it right there. Is 8x cubed a perfect cube? Yes. Yeah, because 8's a perfect cube, right? And x cubed is a perfect cube. What's the cube root of 8x cubed? 2x. What's the cube root of 125? 5. So this would be 2x plus 5. When you go to your a term now is 2x. So when you square 2x, you have to square the 2 and the x. So you get 4x squared. 2 times 5 is how much?
10.
There you get that. Okay. One of the things you might notice if you did FOIL that out, if you multiply 2x and 4x squared, don't you get 8x cubed? You multiply 5 times 25, don't you get 125? It's fantastic.
Yeah.
The alternating signs make the other terms drop out. That's how that works. All right? So that's one of the new things that we're going to do today. Yay. The other one is when you have a lot of mumbo jumbo all mixed together. Lots and lots of grouping.
Can we play the test yet?
I've got one last person finishing that up, and then we'll go up. We look at stuff like this. We are going to be grouping.
Oh dear.
We're going to factor by grouping. Just like we did that one example, we had the 2 and the 21. 2x squared plus 11x minus 21. We split the middle term out, grouped it. Well, now I'm starting with 4 terms. Whenever you start with 4 terms, it's leading you into factoring by grouping. It's trying to get you to group it right away. So, group it. Group it where it is. Remember if that third term is negative, do a quick same change opposite to remind yourself of that. And then just start taking GCFs. What's your GCF of x cubed and 2x squared? X squared. So I factor out an x squared, and I have x minus 2. Take out the negative 9, and I have x minus 2. Are the two parentheses the same? So I have x minus 2 and x squared is 9. Remember, I'm factoring. Can I factor any further? Yes. Is this a perfect square?
Oh yeah.
Is this a perfect square? Is that a subtraction symbol? So what is that factored out?
X plus 3x minus.
So you can continue to factor. You will see that more and more. One other thing. Do I need to solve for zeros here? If I had to solve for zeros, what would this problem have? An equal sign. There's no equal sign, I don't have to get zeros. But let's say I did. How many zeros would this have?
3 zeros.
What was the degree of the polynomial?
I to the third.
So it's third degree polynomial. So what happens here is I'm going to start asking you guys these silly questions about, what's the degree of the polynomial, how many possible zeros can it have? Those numbers should be the same. If it's a fourth degree polynomial, it could have 4 zeros. If it's a third degree, it could have 3. If it's a seventh degree, it could have 7. Doesn't mean it necessarily has, but it could. Okay. Try those two. Let's see. 81x to the 4th minus 16. 81x to the 4th minus 16. That's 2 terms, right? It's got a subtraction symbol here, right? When I start seeing stuff like that, shouldn't I be asking myself, is the first term a perfect square? Is the first one a perfect square?
No.
What is it?
Yeah, 9 times 9.
9x squared.
Good. So that would be 9x squared. Is this a perfect square?
Yes.
Yeah.
What's the square root of 16?
4.
And we already agreed that it was
Peter to the floor.
I can do it again, can't I? All right. I can do that with this one, 9x squared minus 4, but can I do that with the plus 4?
No. Yes.
That's a plus sign. Can I do that? No!
Why? But
Factor, 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 factor.
why can't you do it with plus?
Is 9x squared a perfect square?
Yeah.
Is 4 a perfect square? Is that a subtraction symbol?
No.
Right, I get the y like so you can't. I'll just.
That's the rule. Because you can't get 2 terms that multiply together that are 36 that add together to give you 0. Wow. All right, what about in part B? What's your first rule of factoring? GCFs. So I have 4x to the 6th minus 20x to the 4th plus 24x squared. 4x squared is your GCF. So if you factor out a 4x squared, we have x to the 4th minus 5x squared plus 6. Can I factor that last trinomial? What are the degrees of the exponents? And then nothing, right? So they're cut in half and theirs are going down. It's only 3 terms. Could you have factored this if it was x squared and 5x?
Yes.
How? All right. Well, what is it? What are the terms? What times what's positive 6? Negative 2, negative 3. What changes? Think about it. You're right, it's minus 2 and minus 3.
That
What-
x is still at,
It's got to be an x, but what's the degree? Squared. It's the same idea. X squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. X squared times negative 2 is negative 2x squared. Negative 2x squared and negative 3x squared is negative 5x squared. Negative 2 times negative 3 is positive 6. The rules for factoring, when you're trying to figure out what times what's positive 6 to get to negative 5, those rules don't change here at all, guys. What you look at there is just make sure that your degrees, as long as they're cut in half, it's going to work out just fine. Start with 4 and then goes to a 2. You can factor it the exact same way. Okay? Now, obviously, you're going to bring down the 4x squared with it. Can I factor either of those any further?
yeah,
No, because it does.
No,
The second guy is not
square to the square.
not possible.
4x squared.
Well, how am I going to factor
No,
4?
never mind.
Nothing. There's nothing else to do. Nope.
Nada.
No, there's nothing.
Nada and insada.
That's it. You're done. If it was x squared minus 4, I could have broke it down further. But it's just x squared minus 2. 2 is not a perfect square. 3 is not a perfect square. I can't go any further with that. Now what changed? There's an equal sign. Since there's an equal sign, what do you have to do at the very end then?
Move them over and equal to 0.
Find your zeros. Okay, so I have 2x to the 5th plus 24x equals 14x cubed. What's your first step?
Bring it on over.
Bring it on over. All right, so we bring over. We have 2x to the 5th minus 14x cubed plus 24x is 0. Again, what's your first rule of factoring?
GCF.
Yeah, GCF, and it's 2x. Very good. So if I factor out a 2x, I have x to the 4th minus 7x squared plus 12 is 0. What times what's positive 12? Add the other to get to negative 7. Very good. Negative 3, negative 4. Remember the rule, since my exponents are going down, 4 then a 2, I can just write it out. So it's 2x times the quantity x squared minus 4, x squared minus 3 equals 0. Do I have to factor that any further?
No. Yes.
Maybe. And you're right, I do need to factor it further if it was like this.
Yes.
Because it's an equal sign, I don't really need to, because I can do, and just go 2x equals 0, x squared minus 4 is 0, x squared minus 3 is 0, and I'm still going to get all of my zeros. If you want to factor it all, bless you, if you want to factor it the rest of the way through, by all means. But anytime you get down to the point where you're solving it for a 0, you don't really need to.
I'll
what are my total zeros, or what are my zeros then, guys?
2,
0,
2, and 1 point something.
Square root
I think
of
it's
3.
2.
okay, well, you guys all got points taken off.
Plus minus.
That's what I'm at.
I would have got that.
This is a 5th degree polynomial, right? How many possible zeros should it have? It's a 5th degree polynomial. 5.
Not 6.
0, positive 2, negative 2, positive root 3, negative root 3.
Yeah.
This crossed the
That's
x-axis.
magical.
It's math magical. It crossed the x-axis how many times? 5 times. Okay? That's what we're looking at. Guys, don't forget the rules with plus minus.
I kind of want to see that on the graph.
Lots of issues here. All right, well here, you can rough sketch it. It goes at 0, negative 2, positive 2, and root 3 is in the middle here, right? It's a positive function, right? So it's increasing. So it's going up, down, something like that. I'm thinking. Am I close?
Yeah.
Do this one, please.
Whoa.
And we'll get to rough sketching these things throughout the rest of the chapter. I do have the pacing for the week up there for us. We will get through 6-4 today, 5 tomorrow, 6-6, 6-7 Wednesday, 6-8 Thursday. I don't know how much of 6.9 we're going to wind up doing. We might only do a little bit of it. And then we will test out of this chapter next Tuesday.
Next Tuesday.
Right,
Yeah, we have
break.
the humanities. We always do this last night. That's before break.
Okay. Can't really take it. So,
Okay.
yep.
So far, so good?
Yes.
Plus or minus 2 and negative 7/3? Yes, sir.
Plus or minus 2.
This would be a positive.
Yes. Yes, we subtract 7 divided by 3. Yeah.
So I was right if I put the x squared minus whatever the x minus 2 I think so.
Perfectly fine. There's nothing wrong with that at all.
Then if it's negative, you were 7, 2, and negative 2. It's not bad.
Wait, what'd you have?
Negative 7 over 3.
Oh, I thought you said 7 over 2. I'm like, ah.
But I had
And then you had,
2 or negative 2.
that's fine. It's fine. You're getting the same answers. And like I was telling Daisy, you don't have to factor this further when you're setting it equal to 0, because you're just adding 4 and taking the square root. You can do it that way if you like. It's not a big deal. Fine. But by doing it your way, or what the Daisy was saying too, it forces you to remember the plus minus.
Yeah.
So that's not a bad idea. We just did that one too, didn't we? So as far as the homework and stuff is concerned with this, then, is that instead of giving you guys all the different sections of solve this one by grouping, solve this one by a sum of cubes, solve this one by a difference of cubes, it's giving you the mixture of everything, which means you have to figure it out on your own of what to do first. Remember, first rule of factoring is GCFs. From there, you probably, if you have 4 terms, you're going to want to group them. After that, you just kind of look for your special patterns. Okay? Yes, sir.
Even?
That's what it says. Is that better? You okay now?
Yeah.
So I'll give you guys a little head start here to go ahead and get started. Like I said, I'll put this up also.
I don't even want to start.